Hello. Today I'd like to teach you how to break a vector at an angle into vertical and horizontal components. So you've probably already done this in math, so it's just kind of like adjusting the idea. So it applies to physics as well. So here is a vector, just like we were finding in the last section. It is 16 meters up here, 27 degrees east of the north line. Now that 27 degrees, this is the side adjacent to it. Here's the opposite side, or sorry, here's the hypotenuse, and here is the opposite side for a right triangle. Now, sine theta is just opposite over the hypotenuse, but you can rearrange that to find the opposite side. We want to find our horizontal component of this vector. We want to find out how far we've moved east-west, or in this case, east, I think. Yeah. So if we take this opposite of our hypotenuse equals sine theta, and then multiply both sides by hypotenuse, we can find their opposite side by just putting in the hypotenuse times sine theta. So in this case, our hypotenuse is 16, sine theta is 27. If we plug that in, we end up with 7.3. We are 7.3 meters east of where we started. By exactly the same logic, cosine is adjacent of our hypotenuse. If we multiply both sides by hypotenuse, we got adjacent equals hypotenuse times cos theta. And by the way, these are like the forms you will usually be working in, because generally you are interested in, you've got the hypotenuse and you're interested in finding like your vertical and horizontal components. So anyway, hypotenuse times sine theta to get the opposite side, hypotenuse times cosine to get the adjacent side to the angle you are using. All right, so for this guy, if we want this adjacent here, we just plug her in. Our adjacent, our vertical component is just going to be 16 times cos 27, and that gives us a vertical component of 4.3. So that's how you do this one. Well, let's do the next one. First thing you got to do is draw it out. So we've got, I'm going to start with the north vector. So this is north. And here is the vector we are talking about. Here's our kind of like resultant vector. It is 20 meters. And it is 38 degrees west of the north line. Remember, our second thing is the axis that our angle is touching. So we are going to want our horizontal component and our vertical component. Now, this is the opposite side, so we're going to be using sine. And remember, sine theta equals opposite over hypotenuse. This is our hypotenuse. This is the opposite. We want the opposite, so we will solve for it. We'll multiply both sides by hypotenuse. And so that'll equal 20 times sine 38. Whatever that happens to equal. I will check my handy dandy answer key. So it looks like it is 12.3. So if I go back to, that's 12.3 meters. I'm 12.3 meters west of where I started. And if I want to find my adjacent, so this is my y component, sort of, I don't know, let's call it dy. Then I'm going to find my adjacent side. This is my adjacent. I'm just going to assume you can rearrange it, or maybe not. We'll do cos theta equals adjacent over hypotenuse. And then if we just rearrange that, multiply both sides by hypotenuse, we got our adjacent is equal to the hypotenuse times cos theta, which in this case is 20 times cos 38. So in this case, our x component Oh, crud. I screwed this up before. Sorry. This was our x component. Our opposite was our x component, and this will be our y component. Because this is vertical, that's horizontal. Anyway, so going through that, we got 20 cos 38, whatever that happens to be. Checking the answer key. That appears to be 15.8. And there you are. That's how you break vectors into components. Thanks for listening.